12.6, section 12.6 about outliers, that's going to be a little bit longer, so we're going to go through this. We're not actually going to cover everything in our notes. We've got one or two problems we're going to skip because we're just not going to cover that. But anyway, so outliers. We talked about outliers, I think, before, way back, quite a while ago. We used that term. But outliers are observed data points that are far from the least squares line when we're talking about two data that are related, two variables that are related. They have large errors, and where the error of the residual is the vertical distance from the regression line to the observed point. So in other words, if you think about your regression line, these outliers are going to be really far away from that regression line. When we were doing this before, we were talking about single variable data, and we talked about ages in this class. And then I said, okay, let's say we found the age of everybody in this class, and it was whatever amount. Now let's say we stuck my age in there, and we said, oh, what is that going to do to the average? It's going to pull that average or skew that average one way or the other. And the same thing would happen here. If we've got outliers, things that are really far away from that regression line, it's going to affect where the regression line is, because the regression line is programmed to find the smallest distance for all those points. So if you got one random point way far away, it has pulled that regression line towards it, okay, to try and make that smallest distance. So that's what we're going to talk about a little bit today. How do those outliers affect, and what do we do with them? So as a rough rule of thumb, we can flag any point as an outlier that is located further than 2 standard deviations above or below the best fit line. So just to give you a picture of what that looks like, let's say that our best fit line looked like this. We had data that somehow looked like that, a negative correlation, right? And we have our data, and then what they'll do sometimes, and I know there's a problem in the homework like this, what they do is they will put a marking here that this is the regression line minus 2, and I don't remember what notation they use, but minus 2 times the standard deviation. And then they'll put a marking up here, and this would be that regression equation plus 2 times the standard deviation. And so they're showing you visually, if it's outside of these two lines, it's an outlier, because it's that far away up or below the above or below that regression line. So if we've got points in here, these are all fine, and then all of a sudden we've got this point out here, that's too far away, that would be an outlier. Or if we had a point down here, that would be an outlier. Okay, so you can get an idea visually if things are outliers by looking at the graph and then kind of visualizing those two lines, that they'll go parallel with the regression line, but one will be above and one will be below by that two standard deviations. Okay. Sorry, my wife is texting me. I knew sometimes Elizabeth will text me and let me know she's being late or whatever, but this time it's my wife. And what? It's not super important. I can text her after class, so I'll call her. She just wants a password to something, so it's nothing she needs right this second. So residuals. Remember, residual is the amount of error, the distance between the regression equation and the points. That's the residual. Okay, the predicted value on the line and the actual point that was observed. So residuals play an important role in determining the adequacy of the linear model. In other words, is it a good model or not for what we have in our data? In fact, residuals can be used for the following purposes. So to determine whether a linear model is appropriate, to describe the relationship between the predictor and the response variables. So if your residuals can help us with that. It can also be used to determine whether the variance of the residuals is constant. And it can also be used for checking for outliers. And that's what our focus is tonight, is checking for outliers. If a plot of the residuals against the predictor variable shows a discernible pattern, like a curve, then the response and predictor variable may not be linearly related. So let's think about what that actually means. If you have your points, let's just put my line back up here. So if you have your points and you're graphing this, notice this would be a positive value, right, of fairly large. This would be a small negative value, a little bit bigger negative value, negative value, positive. So we really shouldn't be getting a a pattern with those residuals, right? Because I mean, if it's jumping negative, positive, negative, positive, positive, negative, positive, positive, negative. I mean, it's jumping back and forth. That's kind of random, isn't it? There should be some points above and some points below, and it should kind of be moving back and forth. So we shouldn't get a discernible pattern if we have a good regression equation and a good line for it, and then points that are linear. Okay. Now, on the other hand, if you get something that looks like this, and let's say that we have points that kind of look like this. Now we can visually see that that's not a line, right? A line is not a good fit for this data. This looks like a curve, right? But think about the residual. This one is big and positive, less big, smaller, positive, 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 and now negative a little bit, negative some more, a little bit less, more, more, more. So if we're graphing those residuals, you've got positive, and then it goes down to negative, and then it goes back up to positive again. And so if you think about what shape that's going to make, if you're thinking about a graph, if it's positive and goes down to negative and goes back to positive, and it's probably not quite this drastic, but it's going to form a curve, right? Large positive numbers, smaller, 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 like 0, and then negative numbers, bigger, 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 negative, and then closer to 0, and then bigger, bigger, positive. So the line, when you see this sort of a pattern with your residuals, the line is not a good fit for the data. Okay, so that's what the residual is going to help us figure out. Those two things. If you've got outliers or if you've got a good fit for your data with the line that you're looking at. All right, so here's how we do a residual plot, and you'll see that it's going to be kind of similar to what we did last week with the stat plots. So first of all, we're going to enter our raw data in L1 and L2, just like we did last week. Then we obtain our least squares regression line, just like we did last week. So we did all that stuff last week. Then we're going to go to stat plot, which was this one up here, which, again, we did that last week. Okay, select plot 1, which we did last week, and here's where it starts to get different. Choose the scatter plot. We did that last week. Let X list be L1. That was the same as last week. Let Y list be residual. This is going to be where it gets different, because we're graphing the residual compared to the X values rather than the Y value compared to the X values. Okay? And the way we'll do that, this is how you do it. Moving the cursor to the Y list and pressing second stat. I'll show you how to do that in a second. And choosing number 9 for residual under the names menu. Then we'll press zoom and number 9 for zoom stat. So that is going to be the process. You guys have that on your paper, right? I think. It is? Okay, good. Because you're going to probably want to follow along with that. It's when we pull out the calculators and start looking at it. Okay, so number 12, or example 1215 here, it says a chemist has a 1,000 gram sample of a radioactive material, and this chemist records the amount of radioactive radioactive material remaining in the sample every day for a week and obtains the following data. So we're going to have this data right here. Now, does anybody remember anything about you would have talked about this in college algebra, radioactive materials? Anybody remember how they break down? Or from a science class back who knows when you took science? What happens with radioactive materials is the fact that they're radioactive, they give off electrons, and so they break down into other substances. So just sitting there, they eventually get to have less and less of an amount. Okay? And it usually happens pretty slowly. But let's go ahead and do the data, and then I'll show you what's going to happen. So grab your calculators, or your phones, which have the calculator app on them. And the first thing, again, remember that we want to do is we want to go to stat right here. So stat, and then we want to choose edit, right? So that we can put the values in our list. So I'm going to choose edit. And then remember, from last week, our lists have numbers in them, so we want to get rid of those numbers. So we're going to go up to L1, hit enter, and then clear enter. And go to L2, hit enter, so it turns gray, and then clear enter. And so now we've got that information from last week is gone. Which really, I should have switched this around because we're going to need that information from last week a little bit later. So I just wrecked it. I should have left it. Okay, but remember what we're going to do. We're going to enter in the x values, the top values, in list 1. So that's going to be 0, 1, 2, 3, 4, 5, 6, and 7. Then we're going to go to list 2, and we're going to enter the corresponding output values. So 1,000, oops, and 897.1, 802, oops, 0.5. And you guys can read them on your paper, so I'm not going to read these. And actually, I think I'm going to go on to the next slide. I think I have this information there too. Yeah. So what we're going to do with this data is we're going to draw the scatter plot with the least square regression line. So we're going to find that regression line first. Does anybody remember from last week, once we've entered this data in, how do we find the regression line? What do we do on the calculator to find that regression line? We're going to go, not yet. That's when we want to graph it, we'll do that. We are actually going to go back to stat.
Test.
We are going to do that. We did do that previously, but we're going actually to calculate this time. And we're calculating one variable statistic, or no, sorry, not one variable statistics. We're going to go down to number 4, the regression line. Okay? And then when we hit enter, we don't need to worry about any of that other stuff. We're just going to hit enter. It says X list, Y list, that's fine. And what do we get here? At least as long as I type these into the calculator correctly, this is what I'm getting. I'm getting Y equals the A value, which is negative 75.296 times X, plus the B value, which is 969.025. Is that what you guys are getting?
Yeah.
Okay, good. At least a couple of people said yes, so that means I must have typed it in there correctly. Does anybody need more time to get that number? Okay, so now to do this part, draw the scatter plot with the least square regression line. Here's what we're going to do. The first thing we're going to do is go to y equals, which is this one right up here at the top left corner. And again, you might have something in that equation, you're just going to get rid of it, but we want to put this in. Negative 75 point...
In Y1?
In Y1, yep, 296. And then the x value, remember the x value is right here next to the green alpha key. And then plus 969.025.
Can you repeat that again?
Yep, so we're going to go y equals, and then we're going to, in the y1 spot, we're just going to type in this equation.
Oh, the whole?
Yep. Just what we got on our, when we did our regression equation. So you probably have it on your screen already, but is that not what you got? Oh, well, it wouldn't be on this screen anymore, so you'll have to just copy it from there. But 296x, and then the x is right there next to the green alpha key. That one with all those little variables on it. Yep. And then you'll put in plus 969.025. Okay, so once you've got that entered in, does anybody remember how we see this? And that's where she was going with this earlier, right? Martha was saying we've got to go to stat plot. So if we go second, y equals, so second and y equals, that's the stat plot button. And I don't remember if I hit enter already or not, but we want to make sure that that stat plot is on, and it probably is because we did this last week. And then if we go down, the type should be that one that's just a bunch of random dots. It's the first option, the scatter plot option. And we can keep going down. The mark list one is X, the X list is L1, the Y list is L2. And for right now, that's what we want. Excuse me, that's what we want. Okay? So once we've got all that set up, which most of it already, again, was turned on last week, we're just going to go zoom, and down to number 9, zoom stat.
So when you get a stat plot, you do zoom?
What did I just do here? I just messed my graph up. Ah. Okay. So, no. What did I do? Okay, is everybody else seeing theirs, or mine is messed up at this point in time, so we're just going to set that aside. I'm used to using the calculator, so my phone messes up sometimes. We're not doing a test right now, we're just looking at the scatter plot. Okay, but what does that scatter plot look like? Yeah, it looks like kind of what I drew before, and you've got a few that are above and a few, if I remember correctly, because I did this afternoon, and I think if I remember right, we've got some that are a little bit above, and then it comes a little bit below, and then maybe it comes back a little bit above. Is that kind of what it looks like? There's probably not that many points, but that's kind of in my memory, what it kind of looked like. Okay? And if you look at your correlation coefficient back earlier, the correlation coefficient was really high. Let's see if I can find it here. Second quit. Go back up. Oops. The correlation coefficient, notice the R value, negative 0.994. That's really close to -1, right? And the R squared value, 0.998, or sorry, 0.988. So this model right here, the correlation coefficient would tell us that this is a pretty good model for this data, right? It's pretty linear when you have numbers that are that close to 1 or -1. Does that make sense? We talked about that last week. Okay. Now, what did you get? Did you do it on your calculator?
Mm-hmm.
Okay. Can I see your graph? Oh, you already did the residual. You're a step ahead of me here.
Oh.
That's okay. We'll come to that in a second. Okay. But did everybody get a picture that kind of looked like that? Okay. So the next thing, let's see. The next thing we want to do, it seems that a linear model is appropriate for this, right? And use 3 decimal places when rounding if need be. Oh, the correlation coefficient. Like I said, we just found out that the R squared value and the R value was negative 0.994, which means since it's negative and 0.99, it's really close to a straight line in a negative correlation. And then the R squared value was 0.988. So from all those numbers, it seems like our linear correlation, our linear regression line is a good fit for this, right? Because those numbers are really close to 1 and -1. Does that make sense from what we talked about last week? Okay, good. So let's move on then. And what we want to do now is we're going to look at the residual plot. So if a plot of the residuals against the explanatory variable shows the spread of the residuals increasing or decreasing as the explanatory variable increases, then a strict requirement of linear model is violated. So let's take a look, and we're going to go back and we're going to graph this with the residuals. That's the part that's on your paper there. So we're going to go back to second y equals to the stat plot. And if you remember what we need to do, we need to change, the first part is all going to stay the same. The type should be scatter plot. The second one is going to be, or the X list should be L1, but if you remember, if you look at that next direction, what we're going to change is the Y list is not going to be L2 anymore. Okay? So here's what we're going to do. We're going to clear the L2, and then we have to go to, is it list? I just lost it. What does it say in that paper?
Y list.
The Y list.
Mm-hmm.
And I think that second stat. Yeah, in second stat we go down, we see L1, L2, L3, L4, L5, L6, and then number 7, it says RESID, residual. Okay, and we're going to hit that, and notice it says the Y list now is the residual. So it's going to graph that distance between the line of regression that we just found and the points that we've got. Okay? And then to see the picture again, we go zoom stat. Or not zoom, yeah, zoom and then zoom stat, which is number 9. And my graph is completely messed up. I don't know what happened to this. Yeah, yours is much nicer. That's what I saw on the calculator this afternoon, but on my phone, it's not being very cooperative. What are you guys getting? Are you guys getting a picture on your phones?
Yeah.
And you're getting it looks like a parabola shape, doesn't it? Is that what everybody's getting? Yours doesn't? Mine doesn't. I can't even see the screen. It's ridiculous.
Oh, the thing said 7. I was looking at 7.
Did it freeze?
Yeah.
Okay, I would say just shut it off then. Like double click and shut it off and then restart it because everything will still be there. Well, no wonder it
Okay.
froze. Look at all that
So
stuff.
that gave you-
75 windows open.
Oh.
This calculator, your phone can only handle so much. Okay, so you should be able to. Okay, wait. Clear that off. Go back to. It actually doesn't matter. Just go second y equals. Okay, and then go down.
We're doing this stuff, right?
Could be on.
It's our. I think it's already
We're
the
not doing
white.
this. We're doing these.
Maybe mine isn't.
And enter or what?
You know, look at the.
Oh,
Did you?
so I go here.
And then okay, so where are we at? So
It
we
changes
want to go
that, right?
here.
Yeah.
And then it changes to.
Can you select that on my list?
No. No. What?
You can put a question.
Did you-
second
Oh,
select.
second step. And go to
That's weird. 'Cause mine
reset.
doesn't do that. Okay,
Okay, and then do enter.
so let's see. Let's use our arrows
And
here.
go
zoom step.
Zoom step. No, zoom and then go to zoom in.
Oh,
Yeah.
Okay, so we're gonna change
Yeah.
this one. I think these are your
Oh, they're on
values,
the wrong page.
right? Oh, this is the old one. This is from last week.
I didn't get the light.
I don't know.
Let me in the middle of
Maybe because it froze.
No,
But what we're gonna choose
Let me
is,
double go.
and we're gonna go to second.
Oh,
Whoops, that was wrong one.
That is,
don't
it's okay. You can go ahead. I
We
will.
don't, but I'm gonna come
I will
back.
actually.
Okay,
How-
second.
What week are we doing? I haven't done
This kid is our home.
Stat.
Springfield.
And we go down.
If I don't have comments to the residual, I would have to enter their like
And this one,
to get here for.
we need to check
up
your
an hour.
list may have
Thursday and
changed.
Friday.
Mejor te quedas.
Oh, your list, you're right. Okay, so.
No, no, no. So I'm gonna come in and do homework. A ver si puedo. I'm gonna start with four. We haven't done anything. We have 3 weeks left, I think, to pick up 6 weeks of class.
Okay, and we want that to be L1, so that's
I haven't done it. Because I haven't turned it in.
so that's where we want it to be. And then you should be able to just do zoom. No. Okay, I got it now. I still don't know why I have a bunch of writing on the bottom of it, but do we see what we're getting for our plot? It's a different graph than that. Now it looks like this. You've got like the 0 line, and you've got, it kind of looks like, and there's not many that points again, but it kind of looks like that, right? And what is that telling us? It's telling us that the points start out above the residual, then they go below the residual, and then they come back above the residual line, right? And what that's telling us is, we can see the curve, right? How it's a distinct shape. That's telling us actually a linear, even though for this chunk of the graph it seems okay and the correlation coefficients are pretty good, a line is actually not the best option here for modeling this. That's what that tells us. When you see that distinct curve like that, that's what that's telling you. And in fact, again, if you go back to like your college algebra class or a class you've taken before, exponential or radioactive decay is actually an exponential function. It's not a linear function. So that's why we're seeing this weird thing happen with these residuals, is that we're getting this curve shape, and it's very distinct. Remember what should happen with residuals? They should just kind of be all over the place, above and below zero. Does that make sense? Because it should be kind of random, some above, some below. It shouldn't form a nice pattern like that. Okay? So that is what we're looking at with that example. And so it wasn't strictly increasing or decreasing. We didn't have that, but we did have the fact that it was a shape. And so that's telling us the linear model that we have is not the best option. It still wasn't bad, especially for interpolation. If we were looking in this area, it's actually a pretty good fit. But once we get out further to extrapolation, then we're going to have problems because it's going to be changing. Okay? This is the one we're not going to do. We can look at this, but we're not going to do this one. This is graphing a box plot of the residuals, which is like we also call it a box and whisker plot. You still do it the same thing. You put your raw data in L1 and L2. Then you highlight L3, and you make L3 your residuals. So we're not going to worry about doing that, so we're just going to skip by that one, which means we're going to skip by this one too, which is asking us to make the box plot of that. But I do want to talk about what happens with these outliers, because that's what we were talking about in section 12.6. An influential observation is an observation that significantly affects the least squares regression line's slope and or y-intercept, or the value of the correlation coefficient. So remember how I talked about the outlier would pull that line towards it if it's really far away, either above or below? What that's going to do is it's going to change the slope, or it's going to change the y-intercept, or because it's so far off the line, it'll change the correlation coefficient. Okay, so we're going to take a look at this one, and this is the one that we did last week with the drilling. Remember how long it takes to drill 5 feet? So that's why I probably should have done this one first, because we would have all still had the information in our phones. But what we're going to do is we're going to go re-enter this information. So we're going to go to Stat again, and then Edit, so that we can put in the information. And I'll let you guys do that while I do it as well.
Do we need to delete or just?
You should be able to just type over it, because there are more on this than there are on the one that we just did. But yeah, it's never a bad option to just clear them all off, but I don't think we have to in this case. So once you get that typed in, if you do your just Stat and go to Calculate and do your line of regression. If I remember, I think I just copied this from last week. Yep, so here's our line of regression that we got last week, right? Using these data points.
So we have to go back start.
You'd go to Stat, and then you go down to number 4, the line of regression. And when you hit enter, it's going to tell you
Calculate or test? Calculate.
Calculate.
4.
Number 4. Yep. And then you hit enter, and it's going to give you the A value is, I mean, we rounded it off, but the A value is about this, and the B value is about this. Okay? So that was what we had last week. So I put it on here just for us to double check. But now the question is saying, suppose we added an additional data point to the drilling data. At a depth of 300 feet, it took 12.49 minutes to drill 5 feet. So what we're going to do is we're going to go back to stat and edit, and we're going to add one more point on the bottom of our list. And so underneath the 190, we're going to put in 300. And then underneath the 7.9, we're going to put in 12.49. Does that make sense? Our depth and our time. And then we're going to do the same thing. We're going to find a new regression equation and see what happens. I should have, okay, hang on. Second, quit. I'm going to write down my correlation coefficients here so that I've got those written down. So the R value here on this one is 0.773. So it wasn't a great fit already, but you know that's what we had for the correlation coefficient. So now we're going to find our new
Is it enter or what?
our new regression line. So we're going to go stat, and then over to calculate, and down to number 4 again. Does that make sense? After we put in that point, we'll do the new regression line. And I'm going to hit enter. And I'm getting this time y equals, I'm double checking here, make sure I got the right thing, 0.0212 times x plus 4.443. So you guys are getting? And then the R value here is 0.868 if we round it off. Does that make sense? Okay, so our question that we want to ask then is, is this point influential? Now remember back a couple of slides, we said an influential point is a point that changes the slope, which is this number by the x, significantly, or it changes the intercept, which is this number over here, or it changes the correlation coefficient. Okay? Now that word significantly is a little tough because you got to try and, it just takes some practice to figure it out. But does it seem like our 300-foot information taking 12.49 minutes to drill, does it seem like that is an influential point or not? What do you think? Yeah, it kind of changed. It changed a lot of these things, didn't it? The y-intercept went down over 1, right? The slope went down by, did I copy this right? Is this the right number? Oh wow, that went down a lot then, right? Compared to this is like 0.116, 0.02, if we just left 3 decimal places, this is 116 thousandths, this is 21 thousandths, that's a lot, right? It's still positive, but it's still a lot. And actually, now with that new point, what can you tell us about our correlation coefficient? This new line is actually a better fit with this data than the original line was without that data point. So is this one an influential point? I would say yeah, especially because of this slope. The slope changed a lot. Does that make sense? This slope is like 5 times bigger than this slope. Does that make sense? Okay, so that is, that's telling us that this point right here is an influential point. Probably or possibly even an outlier. We'd have to kind of look at it to see. The fact that it makes this line fit better maybe tells us it's maybe not an outlier, but it definitely is influential. It's changing that line. Okay, and that's the end. So just again, quick reminder, you will be able to use your notes. Make sure that you probably mark in your notes where the calculator steps are, because you're going to want to remember where they are. And make sure you, do your 12.5 and 12.6, but make sure you check out that review. Okay, because the questions on the test are going to be similar, not exactly the same, but they'll be similar to the questions on the review.